Hello. In this screencast, I'm going to give you a glimpse of what happens beneath the hood of Git. First, I initialize a Git repository with Git in it. This gives me the .git directory, which is the actual repository. In here, you'll find the objects directory, which is where Git stores version history as Git objects. Over here on the right, you can see the structure of that directory, and down below, there will be a graphical representation of how the objects relate to each other. Also note the refs directory. This is where Git stores branches, and I'll get back to that at the end of the screencast. Let's first create a file. I'll just put the string important in a file called file.txt. Then I run git add on it, which basically does two things. First, it creates a blob object, which you can see both in the graphical representation and in the directory structure. A blob is simply the compressed contents of a file and does not contain any information about, for example, the file path. Git add stores such meta-info in the index file, which is commonly known as the staging area. Now, let's commit the file using some low-level Git commands. First, I run write tree, which reads the index file and creates tree objects that represent the directory structure of the staged version of the repo. Currently, there is only the root, and you can see here how the labeled edge from tree to blob represents that the tree has a name for the blob. Now, I run commit tree to create a commit object. It needs the hash of the tree to commit, so let's copy that, as well as a commit message. Let's just say add file and pipe that to the command. Now, we have a first version of the repository. To recreate this version, all Git needs to do is to find the root tree that the commit object references, and then follow the named edges from trees to blobs, creating the corresponding directories and files as it goes along. There's now only one key thing missing, and that's branches. Branches are in fact nothing more than human-readable aliases for commit hashes, stored in plaintext files. To create the master branch, I simply copy the commit hash and put it in a file in the .git/ref/heads directory. The file name is the name of the branch, so let's just call it master. Now, you can see that this caused both the master branch and the head reference to appear. Head is essentially a bookmark telling us which branch we're currently on. It's a file at .git/head with a symbolic reference to the current branch, and it defaults to master when the repo is initialized. And that's pretty much everything I wanted to cover. The key point that I wanted to walk away with here is that the basic functionality of Git is not that different from a simple file system. So while Git may seem like 100% dark magic, it's probably more like 50%. Thanks for watching.